In order to demonstrate how motivation energizes, directs, and sustains behavior, we will cover two specific activities in which humans engage in: eating and sexual behaviors. These are vital activities that all creatures engage in. Psychologists are interested in the factors that influence these functions in humans. We will start with a discussion about what factors influence the foods we eat, when we eat, and how much we eat. At its simplest, eating is motivated by hunger, which is usually an unpleasant internal state that directs our attention towards acquiring and eating food. Satiety is the absence of hunger, which can lead to a termination of eating. So when you're full, you stop eating. Early research on eating assumed it was a simple homeostatic system. When hungry, we eat, and when satiated, we stop. Recall, homeostasis is kind of like the thermostat. When it goes low, we turn it up, and when it gets too hot, we turn it down. Now, eating is vital. If we don't do it, we die. And while hunger is one of the motivators of eating, it isn't the only one. So the view of hunger as a homeostatic system is too simplistic, and eating behavior is much more complicated. For example, eating is generally a very pleasurable activity. Myself, I'm a foodie, so I love cooking, talking about food, and of course, eating food. In addition to asking a question about why we eat, what we eat is an additional interesting question to psychologists. Think about what you had to eat over the past couple of days. What did you have for breakfast today? Now I want you to think about why you ate what you did for breakfast. Is it what you normally eat? If so, why did that become your habit? If it wasn't what you normally eat, why do you think you changed? What motivated this? Another question is, when did you eat yesterday? Did you eat 3 small meals through the day? Or 3 major meals? Maybe 1 in the morning, 1 around noon, and 1 in the evening? Or did you eat interspersed throughout the day? Even smaller meals. These are the types of questions that psychologists like to ask about our eating behaviors. Learning underlies much of our eating behavior. We have learned through classical conditioning both what to eat and when to eat. Just as Pavlov's dog salivated at the sound of a bell, we associate certain times of the day or locations with food and eating. Even thinking about food can initiate bodily reactions such as salivation and hunger. Another motivator for what we eat is flavor. Recall that even babies prefer sweet food. Thus, sweet is one flavor most people enjoy and consume. Also important is the variety of flavor. When people are asked to rate the pleasantness of food during a meal, they demonstrate a downward trend as the meal goes on. That is, the more they eat, the less they enjoy it. Sensory-specific satiety describes a related phenomenon in which there is a decrease in one specific food, but not all food. This usually occurs when one food is eaten in abundance. How does this work? Well, imagine that your favorite flavor of ice cream, perhaps it's chocolate hazelnut. That's my favorite. If you were presented with an unlimited amounts of this flavor, you would probably eat quite a bit of it and then stop. However, if you were presented with a variety of different good flavors, you might actually eat more ice cream. An example of sensory-specific satiation can be found when you observe eating in a buffet-style dining. In buffet-style dining, you're presented with so many options that even if you take a little bit of each one, overall you eat more food. Thus, you don't eat just one specific food and then get tired of it. You can go back and forth and try a bunch of different ones. Our brains actually reward us less and less if we eat the same food over and over again. This is adaptive since survival is actually higher for animals that eat a variety of food. Animals that have one specific diet are actually at greater risk. For example, the panda has a very specialized diet consisting of over 99% bamboo. So when this food staple is threatened, either through changes in the environment or competition, they're at greater risk of starvation than omnivores, like us humans, that are able to eat of various types of food, but also enjoy variety. Unfortunately, in the evolutionary environment, eating large meals was also adaptive, since it's possible that food may become scarce. While this is adaptive in environments with unstable food supplies, the modern world it could actually contribute to problems such as diabetes and obesity. Which of these pictures is closest to your representation of what a breakfast is? Well, if you're from the United States, the one on the right may fit your expectation of a classic breakfast. If you're from China, the picture on the left may be closer to what you've come to expect with breakfast. What this demonstrates is that our culture has a very large impact on what we eat. Human beings tend to enjoy things that are familiar to them, either through personal experience or cultural beliefs. Again, this is adaptive, since unfamiliar food could be poisonous, dangerous, or we may not be able to digest it. For example, many people from cultures that don't have a history of eating a lot of unprocessed dairy, such as China, haven't developed lactase persistence. Lactase persistence is the activity of lactase enzyme into adulthood, which is needed to digest the lactose in milk. In addition to genetic differences in our ability to digest food, is cultural learning about what food is. Think about what defines food from one culture to another. What comes to mind when you think of Mexican food? What about Indian food? Or Chinese food? Cultures have their own cuisines, which are the norms for what constitutes food and includes the basic ingredients, the characteristic flavors, and modes of preparation. Culture can also define what foods are taboo or not to be eaten. For example, consumption of dog meat is taboo in Europe and North America, and eating cows is taboo to Hindus. Religion is a large factor in determining food taboos. For example, kosher foods are those that are acceptable for Jewish dietary law. Similarly, the Islamic faith has foods which are halal or lawful, or those that are haram or unlawful. Both the Jewish and Islamic faiths ban pork, which could have been adaptive historically due to protecting against harmful bacteria from incorrectly stored meat or unhealthy hogs. Whatever the source of religious, cultural, or even family preferences for food, these preferences have powerful effects on our own behavior. Even for people who like to try new things to eat, sometimes it's difficult to step outside of our prior experiences and expectations. For example, while I was in Mexico, I was asked to try chapulanes. Please forgive my pronunciation if I got that incorrect. If you're not familiar with these, they're grasshoppers, which are toasted and then seasoned with salt, lime, and garlic. Even as someone who loves trying new things, I hesitated when presented with this snack. To my cultural and familial background, insects are not food. However, I did try them, and while I liked the taste, the texture was not my favorite. Now, our preferences for foods may change over time. For example, if I attended a lot of sporting events in Mexico, in which toasted grasshoppers are sometimes served as a snack, my impressions and taste for them may change. As you can see in this graph, how often we encounter food, that is, how familiar it is to us, the more likely we are to eat it. So something that might be unfamiliar to begin with can become our favorite food. I think about sushi, which, where I grew up in Canada, is very uncommon. When I was 13 and moved to California, my family went out for sushi for the very first time, and the first time I tried it, I wasn't a very big fan. I didn't hate it, but I wouldn't seek it out regularly. However, over time, going out with friends and family, visiting more and more sushi restaurants, eventually I really enjoyed it, and now it's one of my favorite things to eat. Over 100 years ago, the Austrian neurologist Alfred Froelich, described patients who developed extremely voracious appetites and quickly gained excessive weight. When they died, autopsies showed that they had tumors growing on their hypothalamus, specifically on the ventromedial area. Lab studies on mice with lesions to this part of their brain also demonstrated extreme appetites, known as hyperphagia, and became extremely obese. Mice with lesions on the lateral hypothalamus showed the opposite effect, lack of hunger, known as aphasia, and extreme weight loss. Thus, the hypothalamus is a vital brain structure to eating behavior. The hypothalamus influences eating by integrating messages that indicate hunger from the feeding excitatory neurons or satiation from the feeding inhibitory neurons, much like an off-on system. The hypothalamus also monitors the hormones and nutrients, which we will talk about shortly. Early researchers believed that the source of hunger was in the stomach. Specifically, the contractions in the stomach led to hunger. For example, in 1912, Washburn, a medical student, swallowed a balloon attached to a tube that was inflated in his stomach. Contractions of the stomach were measured by changes in the pressure of the balloon. Washburn and his colleague Cannon reported that changes in the pressure of the balloon corresponded with hunger pangs. However, later studies have not supported this finding. Additionally, people who have had their stomachs removed still feel hunger. Thus, it seems that the stomach has a very minor role in generating hunger and motivating eating. In the 1950s, two theories were developed to explain the indicator in the body that our brains, including the hypothalamus, use to trigger hunger. Gene Meyer proposed the glucostatic theory, which argues that decreases in the level of glucose in the blood trigger hunger. This is a good hypothesis, since glucose is the major fuel in the body, and the only one that our brains can make use of. At the time Meyer proposed this hypothesis, there was no evidence of a mechanism for detecting glucose in the blood. However, research since has found many glucose receptors in several organs in our body. Gordon Kennedy proposed the second theory, which is known as the lipostatic theory, which proposed that changes in body fat storage produce signals of hunger and satiation. Again, when proposed, there were no direct mechanisms known to detect these changes in fat storage. However, a candidate was found in 1995, over 40 years since the theory was proposed: leptin. Leptin is a cytokine, which is a molecule which communicates cell to cell. Recent work seems to indicate that leptin is involved in long-term regulation of fat storage. Animals lacking the gene necessary to produce leptin become extremely obese, and injecting leptin into these animals leads to a rapid loss of body fat. Another hormone, ghrelin, is involved in short-term eating behaviors. This hormone originates in the stomach and surges before meals and subsides afterwards. When people lose weight, an increase in ghrelin motivates additional eating in a homeostatic function. While ghrelin works faster than leptin, it still takes time to kick in. Thus, the advice to eat slowly and pause before getting seconds gives the hormones time to work to increase satiation. As you can see, eating behavior is complex, with many different factors motivating what we eat, when we eat, and how much we eat. In fact, it's so complex that there are entire books written on the psychology of eating. We'll now turn our attention to the biological and social factors that motivate sexual behavior. In the 1940s, Alfred Kinsey, along with his colleagues, released the results of their carefully collected survey of the sexual behaviors of Americans. Through rigorous methods and ensuring participants' confidentiality, Kinsey found that the beliefs that people had about the sexual behaviors of their friends and neighbors were way off, especially in regards to female sexuality. Kinsey and his colleagues found that American men and women were engaging in more premarital and extramarital sex and more masturbation than people thought. Women were previously thought to not enjoy orgasms, but Kinsey found that they did. Additionally, Kinsey found that homosexuality was more common than the majority of people believed. Now, this was the 1940s, when people didn't talk about sex, and was one of the earliest explorations of the topic in modern times. Starting in the 1950s and continuing to the 1990s, Dr. William Masters, a gynecologist, and Virginia Johnson, a sexologist, did pioneering research into human sexuality. They based their research on the observation of over 600 male and female participants as they engaged in sexual behavior. While this sample was biased in that only people who were willing to be observed while having intercourse were included, they uncovered many important findings. One of their most important contributions was the four-stage model of sexual response. The four-stage model of sexual response describes the physiological and psychological responses that occur during sexual activities. The first stage is the excitement phase, which occurs when people start thinking about sexual activity or begin to engage in sexual behavior. The physiological response is an increased blood flow to the genitals, accompanied by a psychological increase in feelings of arousal. The second stage is the plateau phase. Physiological responses include increases in pulse, blood pressure, and breathing. Psychologically, arousal continues to increase, passions take control, and inhibitions decrease. The third stage is the orgasm phase. Physiological response includes involuntary muscle contractions, still more increases in breathing, pulse, and blood pressure, contractions of the vagina in women, and ejaculation for men. The final stage is the resolution phase. Physiological responses include blood pressure, pulse, and breathing returning to normal, and a release of sexual tension. Men at this time enter a refractory period, in which they cannot maintain or achieve an erection or have an orgasm. Women do not have a refractory period and are able to have multiple orgasms. Hormones play a major role in motivating sexual behaviors. The main endocrine glands influencing sexual behavior are the gonads, which are the testes in males and ovaries in females. Androgens, such as testosterone, are more prevalent in males, and estrogens are more prevalent in females, though both males and females have both types of hormones. These hormones increase in puberty and influence the development of secondary sexual characteristics, which we cover in the developmental lectures. For males, sexual behavior relies on having a minimum amount of testosterone. In females, the impact of hormones is much more complex. Increased levels of testosterone in women increase their likelihood of sexual thoughts, desires, and sexual behaviors. Women's sexual behaviors can also be influenced by their menstrual cycle, with women who are ovulating finding masculine men more attractive than women who are not ovulating. Additionally, women who are ovulating report lower self-esteem and higher motivation to find a mate. Another important hormone is oxytocin, which we discuss in the development lectures. Oxytocin is also called the cuddle hormone or the trust hormone. During sexual arousal and during orgasm, oxytocin is released into the blood and may promote attachment and love between partners. As with eating, the hypothalamus is also vital to sexual behaviors. It controls the release of hormones into the bloodstream. Damage to the hypothalamus is often accompanied by changes to sexual behavior, primarily loss of sexual interest. In addition to biology, culture also has a large impact on sexual behaviors. Just as we have norms for what foods are acceptable to eat and how they are prepared, we have norms for what sexual behaviors are acceptable. These are known as sexual scripts. For example, in North America, the sexual script often involves starting with flirtation through nonverbal actions, leading to the male initiating contact, the female controlling whether sexual activity takes place. In addition to general rules, there are often rules specific to each gender, and often there is a double standard for men and women. Can you think of a double standard in America for sexual behaviors? What does our culture think of a man who has had dozens of sexual partners? Does this impression differ for a woman who has had the same number of partners? One very common double standard is that premarital and casual sex are more acceptable for men than women. This double standard still exists in the United States, though evidence suggests that it is decreasing. Across all cultures studied, males have demonstrated higher levels of motivation for sex than females. However, while this seems to be a universal finding, culture, social factors, and the environment can influence sex drive. Baumeister called this process erotic plasticity. Research suggests that women have higher levels of erotic plasticity, with their sexuality changing and adapting in response to environmental factors, such as education level and religion, more than men, whose desires tend to remain stable across their lifespan. To account for sex differences in erotic plasticity, as well as males' increased level of motivation for sexual activity, the evolutionary psychologist David Buss has proposed the sexual strategies theory. Sexual strategies theory maintains that women and men have evolved different mating strategies because they face different adaptive problems over the course of human history. The strategies used by each sex maximize the probability of passing along their genes to future generations. According to sexual strategies theory, women are more likely to be more cautious about having sex because having offspring is much more intensive commitment for them than it is for men. This theory argues that men will be motivated to engage with multiple partners than women, since women are biologically fixed in how quickly they can have children, while men are not. This theory is not without controversy, and recent theories suggest that the sexual strategies of both men and women can vary depending on the environment. While there is controversy about aspects of sexual strategies theory, there are some studies that support it. For example, in one study, male and female university students were approached by a stranger who stated, "I've been noticing you around campus. I find you attractive." And then they were given one of the following. Would you go to bed with me tonight? Would you go out to coffee with me? Or would you come home with me? What do you think they found? Who is more likely to say yes to casual sex? You probably are not surprised to learn that more men said yes to sex. In fact, 0 women said yes to sex, and over 70% of the men did. Interestingly, men were more likely to say yes to sex than to a date. As you can see, men and women were equally likely to say yes to coffee. So there seems to be some differences between men and women. However, how much is due to genetics and how much is due to cultural learning is hard to say, though the finding that these differences are found in all cultures suggests it's probably both. There's a short video this week that replicates this study. It's very interesting and I think you'll enjoy it. I now want you to think about what you find attractive in a mate. What are the characteristics you value and look for when thinking about dating? If you're currently in a relationship, what was it about that person that drew you in? Do you think men and women differ on what they look for? Men and women look for many of the same qualities in potential partners. For example, kindness, honesty, happiness, and attractiveness. Where they differ is on where they focus. Men tend to be more concerned about a potential partner's attractiveness, and women tend to be more concerned with a potential partner's status. By observing behaviors, we find that both men and women value physical attractiveness highly. For example, in speed dating studies, both men and women select the attractive choice over others. However, the greater emphasis by men on attractiveness supports evolutionary predictions that men are concerned with fertility of their mate. which is predicted by attractiveness, and women look for men who can provide support. However, cultural norms also work in that direction. For example, historically, women's primary access to material wealth was through their husbands. Interestingly, as cultural changes take place and women are gaining more access to wealth, they're showing a preference for attractiveness that mirrors that of males. One area of sexual behavior that evolutionary psychology has difficulty explaining is homosexuality. According to evolutionary psychologists, sexual behavior should be adaptive for the purpose of having children or spreading our genetics. So how do you explain homosexuality? There's no question that homosexuality has been a part of humanity for at least as long as we've had records. So theories to explain human sexuality should be able to explain its purpose. Evolutionary psychologists have generated a lot of theories to explain it. For example, having homosexual uncles or aunts allows more individuals to support and raise the children of the heterosexual relatives. However, to date, none of the evolutionary theories have garnered much support. So we may not be able to describe the why, but psychology and biology have shed light on the how. Early theories proposed that it was environmental factors, or parenting, that led to homosexuality. For example, one theory proposed that children with a domineering mother and a submissive father would increase the likelihood of having homosexual children. However, an overwhelming number of studies have demonstrated that neither how parents treat their children nor environmental factors after birth have anything to do with sexual orientation. So what is the cause? Sexuality is a complex process, and thus the factors that influence sexual orientation are likely to be complex as well. The best available evidence suggests that exposure to hormones, especially androgens like testosterone, in the prenatal environment may play some role in sexual orientation. Researchers have also found that altering the expression of a single master gene reversed the sexual orientations of male and female flies. However, humans are much more complex than flies, and it remains unclear how human sexual orientation may be encoded in the genes. Some research also suggests that the hypothalamus may be related to sexual orientation. So it appears that homosexuality is strongly biologically based. Some organizations and therapists have proposed that sexual orientation is a choice and can be changed either through therapy, relearning, or prayer. However, no good evidence exists that sexual orientation can be changed. Thus, few psychologists or physicians believe sexual orientation is a choice or that it can be changed through training, therapy, or prayer. Human behavior is extremely complex and can be motivated by many different factors. As you've seen, eating and sexual behaviors are good examples of the interplay of the many biological and social factors that influence us.